For changes in C, we're going to start out the same way. Parent function starts at 0, 0. No changes because it is the parent function. Okay. This is our basis that we want to start with. Now we want to know what's going to happen if we add or subtract something to the end, to the C.
It'll make it move, or it'll like add to where it's at.
Right. I mean, think about when we had linear, we said it moves every point up that many units. So the same thing here. If I start at 0 for x, I'm not going to get 0 over here. Because 0 squared plus 2 is what? 2. So what happened is instead of starting here, we moved up and we started here. However, if you didn't have anything different in front of x squared, is our width any different? No. So the difference is here. If our parent function was originally like this, all we did was move up 2 units. Now, I want to caution you because when you see this and not the equation, it asks you what's the difference in the parent function. A lot of times you have the choice that it's wider. This is not wider. Okay, if we look at this in our calculator, and we have y equals x squared and y equals x squared plus 2. And I graph both of these. It may look like your parent function is wider than that. But if you were to be able to take this graph and slide it up and down, this point goes to this one goes to this one, they each correspond. It's not a change in width, it's a change in where you started from. It'll catch up if you were to slide them together, they're going to be on top of each other. So don't say, when you first look at it, just say, well, it's wider. If it doesn't start in the same place, you need to go back and look at that letter in front of x squared, because it doesn't necessarily mean that. So, it moves up 2 units. So where is our vertex or our starting point now? 0, 2. So then, if we have 1 squared is 1 plus 2 is 3. Negative 1 is the same thing. The easy thing about parabolas is they're symmetric, fold them in half. So whatever you get for the positives, you're going to do the same thing for the negatives. So if we go to 2, what are we going to have? 6. And negative 2 is also 6. This is a 3. So this is the same, the letter at the end, the C does the same thing that it does for linear. It's going to move every point of your line up or down, depending on what you have at the end of that number. So if that one went up, and this is supposed to be equal, by the way, yours I think may be there. Mine doesn't show up. So subtraction would be doing what?
It'll like go down.
It's going to have to go down. So instead of starting at 0, 0, we're going to start at 0, negative 2. Because if x is 0, we're going to get negative 2. So this time, we're going to be starting here. But we didn't change what's in front of x squared. This is still 1. So if our original function is this, then this function is still this. No wider, it just moved down. Don't think it opens down because you have a negative at the end. The number in front of x squared is what indicates steepness, wide, narrow, up or down. This number tells us what's happening with the whole graph, every point. So, in this case, we have 1. We get negative 1. If we have 2, we have 2. And we can go the other way. You get our point? So what's going to happen on the next one?
Go up 3.
You're going to go up 3. So this will be starting at 0, 3. And so 1's going to be 4. 2's going to be 7. Now, there are many, many, many variations with our quadratic. Obviously, we can add in the middle term. We could have something in front of x squared and something different at the end. This is your basic what happens to it. We did the same thing with linear. We changed a whole bunch of factors, and we talked about what happened to the graph. So this is our basic idea. Whatever happens at the end, positive moves it up, negative moves it down. In front, that's going to change your width or your direction. Anything else we add in, we have to take that into account. So it may adjust it a little bit, and we'll talk about those as we get to them. But these are our basic ideas.